Okay, chapter 9.3. We're going to be combining chapter 9.1 and chapter 9.2 uh, together and come up with chapter 9.3. First of all, let's talk about chapter 9.1. Um, Here, just a little review of it. If I give you guys a right triangle, okay, and I call this the angle theta, and then you can instantly say that this is the opposite side of the theta, and this is the adjacent side of the theta, and this will be hypotenuse. Okay? And if I ask you, what is the sine theta? You know it's going to be opposite over hypotenuse. Okay? If I ask you cosecant theta, and then you know it's going to be the reciprocal of sine theta, that's going to be hypotenuse over opposite. Okay? And then if I expand it more, maybe like secant theta, you know that's going to be the reciprocal of cosine theta. So that would be adjacent. Nope, sorry. It's going to be hypotenuse over adjacent. So on and so forth. Okay. Um, let's talk about 9.2. So 9.2, what happened there? I give you guys XY axis and I'm asking you guys, okay, so draw me a terminal side of 135 degrees. And then you know that this terminal side needs to pass 90 degrees, the first quadrant, and you have to go 45 degrees more, and then you just come up with the terminal side. So you're going to combine these two knowledges together, and then let's deal with the 9.3 right now. Okay, so um, this is what happened here. So if I give you guys the XY axis, and I'm going to give you guys a circle around four quadrants like this. Okay, and I said that any terminal side you want to draw, for example, like this. Okay, this terminal side is going to intersect with the circle at one point like this. Okay, now there's a couple components we're going to be naming. Okay, first of all, what is this segment inside a circle from the center to the circumference? Give you guys 2 seconds. Pause. All right, so this is going to be radius. Okay, R represents radius. And then the point intersect, it's going to be a coordinate x, y. Okay, so if I give you guys a coordinates of x, y, you would know that. Sorry, let me put this r somewhere else. Okay, r right here. Okay, so you guys will draw this point one straight line to the x-axis and make it a triangle. Okay, this is the radius, which is the hypotenuse. Okay, if this is this point and then the x coordinate given with the value is basically going to be the value of this horizontal line on the right triangle, and then the y value is basically going to be the vertical side of this right triangle. Okay, so with that being said, you guys will have sine theta, which is, well, theta is going to be right here. It's going to be the angle close to the center. So it's going to be opposite over hypotenuse. So it's going to be y over r. And then cosine theta, it's going to be adjacent over hypotenuse. So it's going to be x over r. Okay, so on and so forth, you'll be able to come up with all 6 trig functions. Okay. All right, let's get started. Some questions here. All right, so first of all, you guys will be giving with the point coordinates of a point. So what you guys gonna do is draw one extra line down to the x-axis and then make it a right angle and call this the theta. Okay, and then we're gonna bring this out to the side. Okay, here is my right triangle. This is theta, and this is the x value. So x value is going to be the horizontal line. So this is going to be negative 13 right here. This is the y value. Y value is going to be the vertical. So it's going to be 6. Okay. Now you just have to come up with the radius, which is the hypotenuse. So you use Pythagorean theorem. So 6 squared plus negative square root of 13 squared equals to r squared. So this is 36 plus, make it a positive 13 equals to r squared. So your r squared equals to 49, your r equals to 7. Keep in mind that you could have negative value for one of the sides, but your radius is always going to be positive, okay? Because use Pythagorean theorem is always going to be positive. So number 2, can you erase this? I need more space for the 6 trig functions. All right, let's come up with the 6 trig functions. All right, so sine theta, it's going to be opposite over hypotenuse. So it's going to be 6 over 7. And then cosine theta is going to be adjacent over hypotenuse. And then tangent theta is going to be opposite over adjacent. Okay? You need to rationalize the tangent theta. Let's do that later. Now we're going to have cosecant. It's going to be the reciprocal of sine theta. So it's going to be 7 over 6. And then secant, it's going to be the reciprocal of that. It'll be 7 over negative rad 13. And then a cotangent is going to be the reciprocal of tangent is going to be negative 13 rad 13 over 6. Okay, just a couple of them that needs to be rationalized. So this one, we can rationalize it by multiply by rad 13 over rad 13. So that will be negative 6 rad 13 over 13. Okay, this one, same thing. Okay, 7 over negative rad 13 times rad 13. Okay, so this one will be negative 7 rad 13 over 13. Okay, that's how you rationalize it. So I just came up with 6 trig functions for number 2. Now let's get started with number 4. So draw a line from the point to the x-axis. You come up with the right triangle with the angle theta over here. Okay, so I'm gonna migrate this out. Okay, so this is my right triangle. This is angle theta, and then let's name all 3 sides. So we have, this is the x value. So x value is going to be right here. So this is going to be rad 7, and this is the y value. So it's going to be right here. Okay, let's come up with the radius or the hypotenuse. So it's going to be 3 squared plus rad 7 squared equals to r squared. That's going to be 9 plus 7 equals to r squared, and that's going to be 16 equals to r squared, so r equals to 4. It's always going to be positive, okay? Now let's come up with the 6 trig functions. Okay, so this is the reference angle. Use a different color here. Sine theta. So sine theta is going to be opposite over hypotenuse. Cosine theta is going to be adjacent over hypotenuse. Tangent It's going to be opposite over adjacent. Okay, cosecant. It's going to be 4 over 3, which is the reciprocal of sine theta. Secant. You just flip it. Okay. Cotangent. Just flip it. Okay. So you gotta have to rationalize all the ones with a radical on the in the denominator. So let's do that. This one needs to be rationalized too. I'm going to just skip the step. You can do this on your own by multiplying rad 7 over rad 7. So this one is going to be 3 rad 7 over 7. This one right here, it's going to be 4 rad 7 over 7. Okay, that's number 4. So number 7. Okay, so you're going to draw this point with a straight line to the x-axis and come up with the right triangle. Looks like this. Okay, and here we got your theta, and then this is the x value, so that will be -2 right here. This will be your y value, so it's going to be -19 over here. Okay, let's come up with the radius, which is the hypotenuse basically. So you got -2 square plus -19 square equals to r square. Okay, you guys will have to do some calculation right here. So you will have 4 plus 361 equals to r squared. Okay, so let's see, you got 365 equals to r squared. All right, so what's going to happen is that your r squared is going to be square root of 365. That's crazy, man. So let's erase this. Square root of 365. Okay, see, we can simplify this. 365, that's 5 times 730. Okay, no, sorry. Okay, so let's just go ahead and let's get started. That was a bad question, man. I'm shocked, man. I gave you guys a bad question. Okay, so sine theta is equal to opposite over hypotenuse. So -19, that's the opposite side over hypotenuse is square root of 365. Okay, cosine, you're going to use adjacent, which is -2 over hypotenuse, square root of 365. Tangent is going to be opposite of adjacent, so opposite over adjacent. Okay, let me erase these for more space. And then you guys got cosecant. That's going to be the reciprocal of the sine, so rad 365 over -19. Secant is the reciprocal of cosine, so that's going to be rad 365 over -2. Cotangent, it's going to be 2 over 19. It's negative, okay? You can make it into positive, okay? All right, so let's simplify some of the stuff. Actually, to be honest, it's not going to be that difficult. You just multiply by rad 365 over rad 365. You should come up with -19 rad 365 over 365. This one is going to be negative 2 rad 365 over 365. And this one, make sure that 2 negative makes it a positive, so 19 over 2. Okay, that's good for number 7.